This video is going to teach you how to do a really good IA1 PSMT and also get really good at bivariate data for the external exam. The reason for making this video came from a question from my Facebook forum asking about the analytical procedures and appropriate calculations to do one of these pretty common PSMT tasks for general maths. From our analysis of the past papers for the external exam for general maths, we know that on average about 20% of the marks on the external exam are for bivariate data also. So I'll get straight into some bivariate data. Here's a table of some bivariate data. Notice there's two variables, the explanatory, typically the X, and the response on the Y. It's the teacher's favorite topic, trying to convince you that there's an association between the number of hours you study and the ATAR that you will achieve. So if we were doing a PSMT, we'd make a bunch of assumptions here, assuming that 6 pieces of data is sufficient, assume the students completed their school in the same year, assuming they studied basically the same subjects, got given the same opportunities to do homework. Basically assuming a bunch of stuff we're not sure about, but hopefully is true to make our solution valid. We'll also make a bunch of observations about the way that we collected this data, about the question that we asked the survey recipients, how they reported their ATAR, how did we get them to round to just one decimal place, how did they round their weekly hour study, was that during term or averaging through the whole year. All these observations just documenting in a real deep sense how we collected the data and what we assume about this process in general. So once we're happy with our data collection, obviously 6 is not good enough, but that'll give us something to talk about in the limitations of our report. We typically want to make a scatter plot of our table of data. So there's a scatter plot, making sure we label both the axes. We'll first examine it for any outliers. When we're talking about outliers in the bivariate sense, this person is probably not an outlier. In bivariate data, an outlier is someone that doesn't follow the general pattern, not just the fact that they studied a lot compared to the rest of the people. We'd be really looking for some data point that's out here. All these ones basically following that trend, and then this one out on its own. So for this data set, we don't have any outliers. You might have some outliers naturally in your data set, that's fine. So effectively we're looking at this data set and we're trying to determine whether there is an association between the person's ATAR and their hours of study. We'll first do this in a completely visual sense. So there's 3 main things we want to describe visually for our scatter plot. We want to describe the strength, direction and form of any association we see between the ATAR and the hour study. So looking at our data set, I would probably describe this as a moderate relationship. They don't seem that close together, but you might say strong, you might say weak, it's sort of up for debate. If I was to draw a line of best fit or a least squares line through this data, it'd probably look something like that. And I can see it's an uphill slope, so I'd probably say, hey, that's a positive, moderate positive association. And in terms of the form, it seems like it's generally forming a straight line, so I'd say it's a linear relationship instead of a non-linear relationship. So if that's all you can do on your assignment, pretty much enjoy your 8 or 9 out of 20, and on the external exam, you might get a few marks, so you won't be the lowest person in the state doing the external exam. So we really want to be a bit more analytical and have actual numbers for strength and direction, and actual way to determine whether it's linear or not. And these are the analytical procedures that we'll go through, starting with strength and direction. So I recommend using Desmos to do the statistical calculations. We can get Desmos to fit a least squares regression line, a line of best fit, whatever you want to call that line, through the data, and it'll tell us some important statistics about it. most importantly at the moment, the R value. We've got an R value of 0.8955, and there's heaps of charts out there for you to classify this R value. This one is between 1 and 0.8, so it would be a strong positive association. Notice that Desmos also gives us the gradient and the intercept of that straight line. So we can put those two coefficients into our y equals mx plus c formula, and we can see what the equation looks like in terms of y's and x's, or alternatively in terms of our ATAR and our study hours. It's probably a good idea for us to interpret what the gradient and intercept mean. So the intercept here of 73.1 is effectively what you would the ATAR that you would expect someone to obtain if they did zero study. The meaning of the gradient of 1.33 means that on our line, as we increase the hours of study by 1, we also increase the ATAR by 1.33. So for every extra hour you study per week, we're expecting an extra 1.33 on your ATAR score. So that right angle triangle, just effectively doing these little triangles all the way up that graph. In your task or in the external exam, you might be asked to predict if someone studies 8 hours a week, what ATAR would you expect they get? So either using the graph or putting 8 in the x value in the equation. You can predict that. It's called interpolation. You should generally be pretty okay with that result. However, if you're asked, well, how many hours does someone need to study to get that elusive 99.95? Okay, again, either using the graph or using the equation, you can also predict how many hours they need to study. You need to be careful with this one because that's a process called extrapolation outside of our data set, and we need to make the assumption that that relationship that we've found continues beyond the data that we collected. So we should be pretty happy. We've got a number, this R value, 0.8955, to satisfy our strength and direction. But you may be thinking, hey, that was a bit too easy. I just pressed a few buttons on Desmos. Do I need to do anything else? Well, you do have some options of things that you can do to check the reasonableness of it and possibly get some more grades on your PSMT. So you've done it on Desmos, do it with another technology. Check it with Excel, check it with your scientific calculator. Okay, make sure that that R value and that equation of the least squared line is reasonable by verifying it by solving another way. So you can also check your R value with the slope of the least squared line. So looking at our one, we got a strong positive relationship. We can see from that line that it's in a positive direction and we have a positive gradient, all things lining up towards us having a correct solution. Some teachers are particularly keen about you doing things manually to check as well. So you can actually calculate R and the equation of the line of best fit or the least squared line manually using these formulas on your formula sheet. So if your teacher's shown you how to do these formulas, it'd be a great idea for you to also do that on the exam, the internal exams, and on your PSMT. The questions involving the formula sheet typically come up more in the complex, unfamiliar parts of the external exam, but your teachers may be particularly keen on these and it might appear really frequently on your internal assessment, in particular your exam for Unit 3. And there's just a little bit of text down here reminding us about how to interpret the least squares regression line. So I've done a lot of work on R, which told us about the strength and the direction. Now let's have a look at the form. The way that we're going to determine the form is through a residual plot, where we're going to look at the actual ATAR, subtract the expected ATAR for each point, and plot it against the hours of study. So effectively, from this scatter plot that we have, we're looking, hey, this point's a little bit below our least squared line, this point's a little bit above, this is a bit above, this is a bit below, a bit above, measuring all those distances and plotting it against the number of hours that each person studied. So what we're looking for is that when we do that residual plot, that there is no pattern. If we have no pattern at all in our residual plot, like this one, it's a linear relationship. If we find that there's a pattern, like a non-linear pattern, then we've missed something on our scatter plot that, hey, we shouldn't have fit a straight line there. It's not a linear association. There's something else going on. So again, this is why I like Desmos. It's got a button you can press that will produce the residuals and also do a residual plot for you. So here we go. Here's my data set and here's my residuals. This is below, above, above, below, above, below, just like we saw on the graph. And here's my residual plot. I don't have much data, so you can probably debate all you want about whether there's some sort of pattern there, but I'm going to say that those dots are pretty much just randomly above or below the x-axis. There's no real pattern there, so I'm going to be comfortable saying that my scatter plot was a linear association. For your IA1, I would recommend just checking a few of those calculations manually to justify the reasonableness of your residual plot. So we're happy. We know the strength, the direction, and the form of our scatter plot, and we have some analytical procedures to support those statements. So we close our laptop, finish the exam, we're done. No, not quite. There's one other thing that we'll calculate called the explanatory power of the model. This is already calculated for us on Desmos, this R squared value of 0.802. So what we need to do with our R squared value is convert it to a percentage. So the idea of the R squared is that percentage, the 80.2%, which is your R squared converted to a percentage. The students that we surveyed, they all got different ATARs. Okay, why did they get different ATARs? What could explain that? Does the hours of study explain it? Well, 80.2% of the difference in people's ATARs, the variation in their ATARs, is explained by the amount of study they did. That's what this R squared value tells us. Okay, so you might think, well, what about the other 19.8%? That could be a variety of things. Could be what primary school they went to. Could be do they need to do lots of part-time work? Do they prepare well for exams? General ability, things like that. Okay, so you can obviously have a discussion about that. And in terms of what else can we check for reasonableness, we can check that our R value that we calculated before, 0.8955, we can check that when we square it, we get the R squared value. Okay, so it's just another little check that you can do along the way. Is there anything else we should discuss regarding the R squared? Yep, absolutely. So we're not saying that we're 80% sure that the studying caused the better ATARs or anything like that. Whenever we're doing bivariate data, there's always some risks. So one of the risks is the common response. So both of those things that we measured, the hours studied and the ATAR achieved, they could both be responding to something else. So if we've got student ability and prior knowledge, if we can measure that, maybe students that basically are smart and have studied in the past, maybe those students study more and also get higher ATARs. So we haven't actually found anything that causes the better ATAR. The hours study and ATAR both are things that good students with good prior knowledge may do. And there's also the chance that there's just a coincidence or some sort of confounding variable that the higher ATARs may have been caused by something else altogether. Like, for example, more effective teaching rather than increased time studying. Okay, it could be just a coincidence that those students that studied for a long time got better ATARs. So when we zoom out and take a bigger picture view of what's happening in bivariate data, hopefully we can see some interrelationships between the visual statements that we can make and the analytical calculations that we can do to justify those same results. If you want to get a copy of that big sheet from our website, in our Unit 3 and 4 support resources, there's some general math support, and you can download a PDF of this whole presentation that you can use basically as a little cheat sheet or checklist for your IA1 or your study of bivariate data. If you need extra assistance with general maths, we have a Facebook group called General Maths Queensland Keep Up Maths Tutoring 2024, where I basically let people post questions and I create a video response to them. So there's that question that I'm effectively responding to today and some previous questions from prior years. So definitely keen to help, and good luck for your general maths journey, especially for bivariate data.